Hi everyone, it's Sorkin. Today we have a problem when we need to find median from data stream. What's the median? Median is the middle value in an ordered array. So for example, let's take this array with the odd size of 5, and in this case the median of this array is just the middle element, which is 3. So let's take another example. Let's say that we have this array with the even size of 6, and in this case the median of this array is middle two elements, which is 3 and 4. Averages of middle two elements, 3 plus 4 divided by 2, so which is 3.5. So what we need to do in our case, we need to implement two functions: add num, which is adding the value that we are receiving to our array, and find median, which is when we call find median function, it returns us the median of that array. And the time complexity for them should be, for the add num should be log n, and for the find median it should be constant, it should be of 1. So how we are going to do that? Let's first take a very simple approach. Let's say that we are using an array, and we are so the add num, we call add num function, and we are adding 1, and then we call find median, which is we have only one element and the median is 1, and then we are calling add num 3, so we have two elements, which is 1 plus 3 divided by 2 gives us 2. So then we are calling add num 2, so we are adding one more element, 2, right, in our array. But what we need to do before returning our median, we need to sort this array, because we have now our elements are in unsorted order. So we have 1, 3, 2. We need to sort our array, and then we need to, when we call find median, we need to return 2 as a mid element of our array. Then we are adding 5, and our median is 2.5, and the last one we are adding 4, so our median is just the middle element, which is 3. So what's the problem with this approach? The problem with using an array for storing our data stream and for returning a median is that in this case, every time we call add num function, we need to sort our array. So our time complexity, even if we use the best sorting algorithms, let's say that we are using merge sort or we are using quick sort, our time complexity is going to be of n log n. So we cannot use this approach, so we cannot use this array. So which approach we are going to use? Instead of using an array, we are going to use a heap. We are going to use two heaps. We are going to use max heap, and we are going to use a minimum heap. So heap is just it's just a binary tree data structure. In the max heap, the root element is the maximum element in that binary tree, and in the minimum heap, it's the minimum element in that binary tree. So what we're going to do is, in our case, we are going to store in the max heap, we are going to store smaller half of the array of the elements that we have received so far, and in the minimum heap we are going to store larger half of the array of the elements that we have received so far. So for example, we are calling add num, and we are adding that to our maximum heap. Then we are calling add num, so we are calling add num, and we are adding 3, so we are adding that to minimum heap. When we are adding elements to the minimum heap, the number of the elements in the minimum heap and the maximum heap should be equal, or maximum heap should, if we have added an odd number of the elements, if we have added even number of the elements, then in that case the number of the elements in the minimum heap and maximum heap should be equal. But if we added odd number of the elements, then maximum heap should have one more element than the minimum heap. So we are again calling add num, and we are adding 2. So now we have in our maximum heap 1 and 2, and the minimum heap 3. So we are adding now 5. Now we have in our maximum heap 1, 2, and in our minimum heap we have 3, 5. So if we are going to call the find median function, so what we are going to do is we are going to take the maximum element. So we are going to take the maximum element from the first element, the root element from the maximum heap, which is the largest element in that heap, and we are going to take the minimum element, which is root element, which is the minimum element in the minimum heap, and we are going to divide that by 2, which will give us our median. And that's for the even case. That's when we have we have even number of the elements in our max heap and the minimum heap. And let's say we are adding one more element, we are adding 4. When we are adding 4, what we do is we are taking the value from the minimum heap and we are adding that to the maximum heap, and we are adding new value 4 to the minimum heap, because the largest element in the maximum heap, so the root element of the maximum heap should be less than the root element of the minimum heap. So because in the maximum heap we are storing smaller half of the array, and in the minimum heap we are storing larger half of the array. So in this case, what's going to be our medium? Medium is in our case median in our case is just the peak element from the maximum heap, the root element from the max heap. If we are using max heap and the minimum heap, two heaps instead of the array, our adding to the max heap is adding to the binary tree. So adding to the binary tree, the time complexity of this approach would be log n. First thing that we do is we are initializing two variables, max heap and the minimum heap. So for our add function, in our add function, what we do first thing, we are adding the value that we are receiving, so we are adding that to our maximum heap right away. In the next one, we are checking that if our maximum heap and the minimum heap, if they are not empty, and if the value in the maximum heap, root value in the maximum heap, is more than the root value in the minimum heap, so we are adding to the minimum heap value from the maximum heap. So for example, let's say that we are adding to the maximum heap element right away, right? So let's say that in the maximum heap we have 1, 2, 4, and in the minimum heap we have 3. So and we are comparing the root element, which is the maximum element in the maximum heap, and the root element, which is 3 in the minimum heap. So the maximum heap, it should not be the root value of the maximum heap, it should not be more than the root value of the minimum heap, because in the maximum heap we are storing smaller half of the array, and in the minimum heap we are storing the larger half of the array. So what we do is we are taking the value of 4 from the maximum heap, and we are adding to the minimum heap. In the next one, what we do is we are comparing the sizes of the maximum heap and the minimum heap. So if we have odd number of the elements, if the maximum heap should have one more element than the minimum heap. If they are not, then in that case the number of the elements in the maximum heap and the minimum heap should be equal. So for example, in this case we are checking that if the number of the elements are in the maximum heap are more than in the minimum heap. So and if that is, let's say we have 5 elements in the maximum heap, and in the minimum heap we have 3 elements, so it's minimum heap plus 1, right? Because in case of the odd number of the elements in the maximum heap, we should have one more element than in the minimum heap. We are checking if in the maximum heap, let's say we have 5 elements, and the minimum heap we have 3 elements, then in that case we are taking one element from the maximum heap and we are adding that to the minimum heap. We're adding that to the minimum heap, and then we are also doing the reverse. We are checking that if the number of the elements in the minimum heap more than number of the element in the maximum heap. So what we do is we are adding to the maximum heap. We are taking the element from the minimum heap, and we are adding that to the maximum heap. And when we are calling the find median function, so what we do is we are comparing the sizes of the maximum heap and the minimum heap. If the size of the maximum heap more than size of the minimum heap, which means that we have odd number of the elements in our we have received odd number of the elements, so our add function called odd number of times. So in that case we are receiving whatever the root element in the maximum heap. And if they are even, so we are taking the root element from the maximum heap, and we are taking the root element plus the root element from the minimum heap divided by 2. Java implementation is identical. So in Java, implementation of the maximum heap and the minimum heap is done using priority queues. So we are creating two priority queues, max heap and the minimum heap. And in our add num function, in our add num method, so what we do is, the first thing that we do is, as soon as we are receiving an element, we are adding that to our maximum heap. Then we are checking our minimum heap. If our minimum heap is not empty, and if the maximum element in our if the root element in our maximum heap is more than the root element in our minimum heap, then we are adding to the minimum heap element from the maximum heap. So for example, let's say that in the maximum heap we have 1, 2, 4, and in the minimum heap we have 3, right? So because first we are adding, as soon as we receive element, we are adding to the maximum heap. So we are, and the root element in the minimum heap is 3, and the root element in the maximum heap is 4. So 4 cannot be more than 3. So what if it is more than 3, then what we do is we are taking that element from the maximum heap and we are adding that to minimum heap. That's exactly what we are doing here. And the next step is that what we do, we are balancing our max heap and our binary trees, our max heap and the minimum heap. So we are checking that if the size of the maximum, if the number of the elements in the maximum heap is more than the number of the element plus 1 in the minimum heap. Again, if we have odd number of the elements, then in that case we are gonna have in the maximum heap one more element than in the minimum heap. So we are checking that if it's more, if let's say that in the maximum heap we have 2 more elements than the minimum heap, then we are taking that element from the maximum heap. So we are taking whatever is the root element from the maximum heap and we are adding that to the minimum heap. And the same way we are checking that if in our minimum heap we have the size of the minimum heap is more than the size of the maximum heap, then in that case again we are balancing them. So we are taking the root element from the minimum heap and we are adding to the maximum heap. And for the find median, again we are checking if the size of the max heap size is more than minimum heap, which means that we have odd number of the elements, then we are just returning the peak element from the maximum heap. If not, if they have if this number of the elements are equal in the maximum heap and the minimum heap, so we are taking the peak element from the maximum heap and the peak element from the which is the root element from the maximum heap and the root element from the minimum heap, and divide that by 2, which gives us our median. So what's the time and space complexity? Time and space complexity, as we have seen earlier, for add num, it should be log n. It's a log n because it's a binary tree, and adding elements to the binary tree, time complexity is log n for the heap operations. And for the find median, it's constant because in this case we are just taking if it's odd, we are just taking the root element from the max heap. If it's even, we are taking the root element from max heap and the root element from the min heap and divide that by 2. Okay, that's it for today. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.